In this video, we're going to look at two factoring topics. The first is the greatest common factor, and then we'll look at factoring by grouping. So let's start with the greatest common factor. The GCF of two or more numbers is the largest number that divides evenly into all of the numbers. The GCF of two or more single variable expressions is the variable with the lowest power. The GCF of the expressions is the product of the coefficient GCF and the variable GCF. In these examples, we're asked to factor out the GCF, or greatest common factor. So in this first example, we have 7x cubed minus 14x squared plus 21. So the first thing we want to look at is the numeric part. So we have 7, 14, and 21. Now 7 goes into all of these numbers, and 7 would be the largest number that could go into all three because it's the largest number that goes into 7. So my GCF in this case is going to be 7, and then I look at the variable part. I have x cubed, x squared, and then on this last one, I don't have an x on the very last term. So x would not be part of the greatest common factor. And so what I can pull out is I can pull out a 7. Now, let me go ahead and write this as 7 parentheses x cubed minus 7, and what would be left of the 14x squared? Well, 7 times 2 gives me 14, so this would be 2 and then x squared. And then the 21 could be written as 7 times 3. So now I'm using the reverse distributive property, and I'm actually going to pull the 7 out front. So I'll have 7 written out front, and then a set of parentheses. And in the parentheses, I'll have x cubed minus 2x squared plus 3. So it's the reverse distributive property when I'm pulling out the GCF. If I multiplied and put the 7 multiplied by each term, I should get my original expression, 7x cubed minus 14x squared plus 21. So you can always check by multiplying it out. In this next example, we have negative 16y to the 5th plus 48y cubed minus 128y squared. Now, I can see that the variable to the lowest exponent is going to be y squared, so that will be part of my greatest common factor. And then I can also check, I know 16 goes into itself, 16 goes into 48, and if I wanted to check whether 16 goes into 128, I could actually go ahead and use my calculator and do 128 divided by 16. Now, if it didn't go in, then I could go ahead and try a 4 as my next number that I try. But in this case, 16 worked. So I'm going to go ahead and write 128 is 16 times 8. 48 is 16 times 3. And 16 is 16 times 1. So my GCF in this case is going to be a 16, and then the variable to the lowest power was squared, so y squared, 16y squared. So let me rewrite this as 16y squared, and think about, with using your rules of exponents, what would be left over here? So a negative 1 would be left over there, and then y to the 3rd power, because when I'm multiplying like bases, I add their exponents. So the y squared and the y cubed would give me y to the 5th. Now I have plus 16y squared, and I'm looking at the second term. 16 times 3 gives me 48, so I'll have 3 and then y, because y squared times y would give me the y cubed. Now I have minus 16y squared. 128 is 16 times 8, so I'll have 8. I've already accounted for the y squared, so I don't have a variable to multiply in there. So when I factor out the GCF using the reverse distributive property, I get 16y squared, and then in parentheses, I get negative y cubed, and you could write the negative 1 in front of the y cubed, or you can choose to just write it as negative y cubed, plus 3y minus 8. So I've factored out the greatest common factor. Now, when you are doing this, it's okay if you take the negative out with the common factor. And so another valid answer would be negative 16y squared. And if I did that, it would switch the sign of each term inside the parentheses. So if I pulled out the negative, I would have negative 16y squared, parentheses, positive y cubed, minus 3y, plus 8. So it switched all the signs inside of the parentheses. And these are both valid answers for pulling out the greatest common factor. Now, again, if you wanted to double check, you would go ahead and distribute that GCF and make sure that you get to your original expression. Now we're going to look at factoring by grouping. And the reason we're looking at this in conjunction with the GCF is because we do a lot of factoring out the greatest common factor when you're doing grouping. Grouping is good if your polynomial has 4 terms. The reason it's good if you have 4 terms is because you're going to go ahead and group 2 terms together in the first set and 2 terms together in the second set. Here are your steps. Step 1, put the polynomial in order of degree with the highest degree term listed first. Step 2, group the first 2 terms together and the last 2 terms together with a plus between the groupings. This will ensure that you don't make any mistake about factoring out the GCF in the second group. Step 3, factor out the GCF from each grouping separately. Step 4, at this point, the 2 groupings should have a common factor in parentheses. Factor out this common factor and then check your answer by multiplying out the factored polynomial. All right, so let's look at this example. We have 5x squared minus 15x minus 3x plus 9. Okay, so I'm going to start by grouping. So I'll go ahead and label my steps here. I'm trying to group. And so I'll have parentheses around 5x squared minus 15x. Close those parentheses, put a plus. You have to have plus between the groupings. And in my second set of parentheses, I'll have negative 3x plus 9. Now, if the negative was out front in front of the parentheses, that would make the plus 9 incorrect because of the distributive property. So that's why I have to have a plus between my groupings. Now I look at each group separately. So this first group right here, 5x squared minus 15x, I want to figure out the GCF just for those 2 terms. So 5 and 15, the greatest common factor is 5. X squared and x, the lowest exponent is 1, so 5x would be the GCF. So I'll have 5x, and then I'll look at what's left over. In the first term, I've taken out the 5, I've taken out one of the x's, so I just have an x left in the first term. And then for minus 15x, I've taken out 5, so I just have 3 left. And I've taken out the x, so I don't have any x's left. So I have 5x parentheses x plus 3. Now let's look at the second group, negative 3x plus 9. So we're looking for a greatest common factor of these two terms. If there's a negative in front of the leading term in this second set of parentheses, I'm going to include the negative with the GCF. So include the sign of the leading term with the GCF. So when I list the GCF, I'm not just going to say 3, I'm going to say negative 3. All right, so I'll pull out a negative 3 from the second set of parentheses, and I look at what's left. I pulled out a negative 3 from the first term, so I just have x left. If I pull out a negative 3 from the plus 9, that gives me a minus 3 right here. Now here's the important part. The important part is that you have to have these two things in parentheses the same. Those have to be the same, because essentially what you're doing is you're going to count that as the common factor and factor it out. So since those are the same, I can factor out x minus 3 from both terms and then look at what's left over. So I'll have my x minus 3. What's left from the first group is going to be the 5x, and what's left from the second group is going to be minus 3. So I factored out x minus 3 because it was the GCF of these two terms, 5x parentheses x minus 3 minus 3 parentheses x minus 3. So this would actually be my final answer. X minus 3 times 5x minus 3. Notice now there's no plus or minus between the two sets of parentheses. They're multiplied together, so that's factored. And now what I want to do to make sure I got the right answer, I'm going to check my answer. So I want to multiply out x minus 3 times 5x minus 3. And I'm going to go ahead and use the box method here. So I'll put x minus 3 on the top of my box and 5x minus 3 along the left side of my box. So in the upper left rectangle, I get 5x times x. That gives me 5x squared. In the upper right box, I get 5x times minus 3, so negative 15x. In the lower left box, I get negative 3 times x, so minus 3x. And in the last lower right box, I get negative 3 times negative 3, which is plus 9. And if I write that out, that's 5x squared minus 15x minus 3x plus 9. And I just check, is that the same as my original? It is, and so I know that my factored form of x minus 3 times 5x minus 3 is the correct answer. So that's what I would enter for factoring by grouping. So remember, your steps are group the first two terms together and the second two terms together with a plus between the groupings. Factor the GCF from the first two terms, factor the GCF from the second two terms, and then you have to have the same thing in parentheses in your two terms, and then factor that out. And then at that point, that should be your final answer.